So this is our figure that we have been given into our equation here. This one represent the moment of inertia of the ring. This is for you the uniform ring, and this one is for the car mechanical linkage. As we try, they have their distance and also the parallel axis, the moment of inertia through the center, and also the moment of inertia through any axis. So as we try to see even here, we have the axis through the center of mass and also the axis through the point P, as we try to see. They are being separated at a distance P at a distance equals to 0.15 as we try to observe. So using the parallel axis as theorem, we can say that moment of inertia through any axis equals to the moment of inertia through the center we add by the mass times the r square. Now we should substitute here because we are talking for the uniform ring. If we are talking for the uniform ring, we are supposed to substitute the moment of inertia through the center, which is equal to mr square. If we sum, we could obtain that moment of inertia through an axis must be equals to 2mr square. Now let us substitute our given values through our question. We should obtain that moment of inertia for the figure number 1 equals to 1 exponent negative 3 kilogram per meter square, where d is equal to r and also I see represent equals to mr square. Therefore, we could conclude by saying that moment of inertia through the uniform ring must be equals to 1 exponent negative 3 meter. So after this one, for Roman 2 here, we are supposed to go and look for the car mechanical linkage. But for the car mechanical linkage, we could say that moment of inertia, we know moment of inertia through any axis is equal to the moment of inertia through the center we add by their mass product of the mass and also their distance square. But we have been given the moment of inertia through an axis, but we have been asked to find the moment of inertia through the center. Now we could, if we substitute, we could obtain that first of all md square should be equals to 0.0181 kilogram meter square. This is the product of the masses and also the distance square. So after this one, my dear student, let us go and substitute the given values for our formula so that to obtain the moment of inertia through the center of the car mechanical linkage. If we substitute here, we could obtain that moment of inertia through the center for the car mechanical linkage is equals to 0.051 kilogram meter square, and this is the value that we have been asked to find into our equation. So after this one, my dear student, this will be the end of our session here. Now I would like to welcome you again for another session. I wish you all the best. Have a nice moment.